Okay guys, now I'll tell you all about the F distribution. Okay, firstly, let's look at the PDF of the F distribution. The PDF for this F distribution is gamma V1 plus V2 over 2 over gamma times V1 over 2 times with gamma times V2 over 2. This whole thing you times with V1 over V2 to the power of V1 over 2. When you get the answer, you times it with x to the power of V1 minus 2 over 2 over 1 plus V1 over V2 times x to the power of V1 plus V2 over 2. For the CDF, for the F distribution, you integrate from 0 to x gamma V1 plus V2 over 2 over gamma V1 over 2 times gamma V2 over 2 times V1 over V2 to the power of V1 over 2. The whole thing you times with T V1 minus 2 over 2 over 1 plus V1 over V2 times T to the power of V1 plus V2 over 2. Okay, next, the mean for the F distribution. The mean for V2 more than 2 is V2 over V2 minus 2. The variance for V2 more than 4 is 2 V2 over 2 times V1 plus V2 minus 2, the whole thing over with V1 times V2 minus 2 to the power of 2 times with V2 minus 4. The mean is undefined if V2 is less than 3, and the variance is undefined if V2 is less than 5.
Hi, I'm Karana. I'm gonna tell you guys about the basic problems in Cauchy distribution. Okay, now let's go.
So the first problem is, I'm gonna explain about why the mean for the Cauchy distribution does not exist. Okay, first of all, as you guys know, means equal to integration the parameter positive infinity until negative infinity x times with the probability distribution function PDF for Cauchy, a over a squared plus x squared dx. So if you separate the integrals for x greater than 0 and x less than 0, the answer will do not exist. However, if you follow the principle of integral x less than 0, it will cancel the x greater than 0. That means you will get mean equal to 0. This is the explanation. When you cancel the 0 and 0, and then you will get 0. Okay. Second of all, I will explain to you guys the examples of question in Cauchy distribution. For this question, we can prove that two independent variables can be related to the Cauchy distribution. First of all, x equal to z over w has a standard Cauchy distribution. This is for the example question. Example, assuming that student T distribution with 1 degree of freedom. So we can prove that z over square root of w squared is equal to z over w, same as the question above. As you guys know, since you got the power of squared, this will be related to chi squared. So we can expand the distribution. We will get T equal to gamma 1 over square root pi gamma half times with 1 plus T squared power of negative 1. And then the answer, we will get the Cauchy distribution. And I will give you guys the last example. So I will prove to you guys according to this question. Suppose that x has Cauchy distribution with location parameter 0 to infinity. Then y equal to 1 over x has the Cauchy distribution with location parameter 0 and scale parameter 1 over b. Assuming 1 over x has same distribution as 1 over b and 1 over z. By referring to the last problem I given to you guys, 1 over B and 1 over Z has Cauchy distribution with the location parameter 0 and parameter 1 over B.
Hello, my name is Muhammad Azri. Today I'm going to show you the example relating to the F distribution. Okay, the first question of the relating to the F distribution. Suppose you randomly select 7 women from a population of men. The table below shows the standard deviation in each sample and each population. Population standard deviation of women is 30 and for men is 50. Sample standard deviation of women is 35 and men 45. Compute the F statistic. The F statistic can be computed from the population and sample standard deviation using this equation. As you can see from the equation, there are actually two ways to compute an F statistic from this data. If the women's data appear in the numerator, we can calculate the F statistic as this, where the women's data appear in the numerator 35 square over 30 square over 45 square over 50 square, and we get 1.68. On the other hand, if the men data appears in the numerator, we can calculate the F statistic as follow, where 45 square over 50 square over 35 square over 30 square, and we get 0.595. And now for questions 2, prove that mean for F distribution is V2 over V2 minus 2. First, we integrate as fx dx with limit infinity and negative infinity. This can be derived from the integral representation of beta function, as you can see in here, until we get V2 over V2 minus 2.